The frost bit hard that morning in December 1942, somewhere in the grey hills south of Tunis. A German recovery team worked quickly, their breath clouding the air as they wrestled a peculiar object from the wreckage of an American half-track. The vehicle had been struck during the previous day's fighting, its crew dead or scattered. But it was not the half-track that interested Hauptmann Weber. It was the long metal tube one of the Americans had been carrying when he fell. Preparing and narrating this type of story took us long efforts and hard work. So if you are enjoying the story, please consider subscribing to our channel. Weber lifted it carefully. It was lighter than he expected, almost crude in its construction. 2 simple grips, a basic sight, and a wire mesh screen protecting the operator's face. No precision machining, no elegant mechanics. Just a tube, open at both ends. He turned it over in his hands, studying the stenciled markings. M1 rocket launcher. Below that, instructions so simple they seemed insulting. Load, aim, fire. The simplicity unsettled him more than complexity ever could. Weber had spent 15 years in ordnance evaluation. He knew weapons. He understood that German engineering prized sophistication, that their anti-tank rifles were marvels of ballistic calculation, that their tactics emphasized precision and training. But this American device looked like something a farmer might cobble together in a workshop. And yet, intelligence reports from the field told a different story. American infantry were stopping German tanks with these tubes, stopping them cold. Within 72 hours, the captured launcher and 3 unexploded rockets were on a train heading north. Within a week, they arrived at Kummersdorf, the Reich's primary weapons proving ground south of Berlin. And within 10 days, a team of Germany's finest ordnance engineers had assembled to examine what appeared to be nothing more than a pipe with a trigger. What they discovered would reshape German anti-tank doctrine within months and reveal a truth about American warfare that would haunt them until the end. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The proving ground at Kummersdorf had witnessed every innovation in German weaponry since the Great War. Its bunkers held secrets that would reshape warfare. Its firing ranges had tested everything from the first anti-tank rifles to prototype rockets that screamed into the winter sky. But on this particular morning in late December 1942, the assembled engineers stood around a wooden table, staring at something that defied everything they thought they knew about weapons design. Oberingenieur Hans Kroger picked up the launcher first. He was a veteran of the Ordnance Corps, a man who had helped refine the Panzerschreck 39 anti-tank rifle. He believed in German precision, in the careful calculation of every variable. The weight of the launcher shocked him. 6 kilograms, barely 13 pounds. Their standard anti-tank rifle weighed more than twice that, required 2 men to operate effectively, and could barely penetrate the armor of newer Soviet tanks. He examined the construction. Steel tubing, simple wooden grips, basic iron sights, a wire basket to protect the firer from backblast. There was no recoil mechanism because there was no recoil. The rocket's motor would ignite after leaving the tube, the backblast venting harmlessly behind the operator. The entire weapon could be manufactured by a moderately skilled metalworker in a matter of hours. No precision parts, no complex assembly, nothing that required specialized tools or training. Kroger set it down and picked up one of the captured rockets. The projectile was equally crude. A simple steel tube containing the motor, a shaped charge warhead at the front, basic stabilizing fins. At the rear, he weighed it in his hand, 1.5 kilograms, just over 3 pounds, light enough for an infantryman to carry multiple rounds without exhaustion. He turned to his assistant, a young engineer named Dietrich Stein, who had studied shaped charge technology at the Technical University in Munich. "Dietrich," Kroger said quietly, "what penetration would you estimate from a shaped charge of this diameter?" Stein did the calculations in his head, his eyes moving across the rocket's dimensions. "At this diameter? Perhaps 60 millimeters. maybe 70, if the standoff distance is correct and the liner is properly formed. But Herr Oberingenieur, that would be enough to— He stopped, the realization settling over him like cold water, enough to penetrate any tank currently in service, German, Soviet, or American. The team spent the morning examining every aspect of the weapon system. They measured, weighed, photographed, and documented, and with each measurement, the same uncomfortable truth emerged. The Americans had created a weapon of devastating effectiveness using the most basic manufacturing methods imaginable. No part of the launcher required precision machining. No component needed specialized materials. The whole system was designed around a single principle: give every infantry squad the ability to destroy tanks using weapons they could manufacture quickly, carry easily, and learn to operate in minutes. Major Friedrich Wenzel arrived from Berlin just before noon, accompanied by an intelligence officer who carried a leather satchel stuffed with field reports. Wenzel was not an engineer. He was a combat veteran, a man who had fought in France and now commanded a Panzer Grenadier battalion being refitted for the Eastern Front. He had seen what Soviet anti-tank rifles could do, had lost men to them, had learned to respect the desperate courage of infantry attacking armoured vehicles. He listened as Kroger explained the weapon's basic operation, then interrupted. "Theory is interesting, Herr Oberingenieur, but what does it actually do?" Kroger nodded toward the firing range. "We are preparing a demonstration now. We thought you might want to see it yourself." They walked out to the test ground, where a captured Soviet 34 tank sat on wooden blocks, its turret traversed to the side. The tank was a veteran of the Stalingrad fighting, its armour scarred by impacts, its tracks frozen with mud from the steppes. It represented the enemy that haunted German tankers, fast, well-armoured, produced in numbers that seemed endless. A technician stood 50 meters from the tank, holding the bazooka. Another man knelt beside him with the rocket, waiting. Kroger gave the order. The loading procedure was absurdly simple. The second man inserted the rocket into the rear of the tube, connected a simple electrical lead to the firing mechanism, and tapped the shooter's helmet. Ready. The technician shouldered the weapon, aimed using the basic ladder sight, and squeezed the trigger. The sound was not what Wenzel expected, not the sharp crack of a rifle or the boom of artillery. Instead, a whoosh, like air escaping, followed immediately by a roar as the rocket motor ignited. A streak of flame shot backward from the tube, the backblast kicking up dust and snow. The rocket streaked across the range, leaving a thin trail of smoke. It struck the 34's side armour just below the turret ring. The explosion was sharp and focused. When the smoke cleared, a hole had been punched through the armour, clean and precise. 75 millimeters, nearly 3 inches. Straight through armour that German anti-tank rifles could barely scratch. Through armour that required their Pak-38 cannon to defeat at close range. Through armour that had shrugged off hits from Panzer Mark III main guns. The silence that followed was profound. Wenzel walked to the tank, climbed up onto the hull, and examined the penetration. He could see straight through to the interior. Any crew inside would have been killed instantly by the jet of superheated metal. He turned back to Kroger, his face pale. "And an American infantryman can carry this? Can learn to use it in, what, an hour of training?" Kroger nodded. "The manual we captured suggests basic proficiency can be achieved in 30 minutes. With practice, a crew of 2 can maintain a rate of fire of 4 to 6 rounds per minute." Wenzel sat down heavily on the tank's hull. Around him, engineers were already taking measurements, documenting the penetration, preparing for additional tests. But Wenzel was not thinking about tests. He was thinking about his battalion, about the Panzer Grenadiers who would face American infantry equipped with these weapons, about tank crews who would discover that their armour was no longer protection, but merely a metal coffin waiting to be opened. "We need this weapon," he said finally. "Not a similar weapon, not an improved weapon. This weapon, exactly as the Americans have built it." Kroger hesitated. Herr Major, we can certainly design something superior. With proper German engineering, we could improve the accuracy, increase the range, enhance the— Wenzel cut him off. No, you do not understand. This weapon is perfect precisely because it is simple, because any factory can make it, because any soldier can use it, because it does exactly what it needs to do and nothing more. He stood, facing the assembled engineers. How long would it take to copy this? To put it into production? The engineers exchanged glances. Stein spoke first, his voice uncertain. The launcher itself? Perhaps 2 weeks to create production blueprints. The rocket would be more complex. The shaped charge requires precision in the liner. The fuse mechanism needs to be reliable. The rocket motor must— How long? Wenzel repeated. Kroger cleared his throat. 3 months to begin production. 6 months for full-scale manufacturing, assuming priority allocation of resources. Wenzel laughed, but there was no humor in it. 6 months. And how many of these do you think the Americans are producing? The intelligence officer opened his satchel and pulled out a report. Current estimates suggest production began in June 1942. Monthly output is believed to be approximately 5,000 launchers. Rocket production is substantially higher, perhaps 30,000 rounds per month. The numbers hung in the cold air like an accusation. Kroger did the math silently. By the time Germany could begin production, the Americans would have manufactured perhaps 30,000 launchers, perhaps 200,000 rockets. Every American infantry company would have multiple teams equipped with weapons that could destroy any German tank, and that assumed American production did not increase, which, based on every other American weapons program, it certainly would. The tests continued through the afternoon. They fired at different angles, testing the rocket's performance against sloped armor. They fired at different ranges, documenting accuracy and penetration. They fired at a captured Mark III, watching the shaped charge bore through armor designed to protect against conventional shells. Each test confirmed what the first shot had proven. The Americans had created a weapon that fundamentally changed infantry tank warfare. As sunset approached and long shadows stretched across the proving ground, the engineers gathered in a concrete bunker to review their findings. Charts covered the walls, calculations filled multiple chalkboards, but the conclusion was inescapable and terrifying. Kroger stood before the assembled group and delivered his preliminary assessment. Gentlemen, what we have examined today represents a revolution in infantry anti-tank capability. The weapon system is crude by our standards, yes. It lacks the precision we would demand. The accuracy is adequate but not exceptional. The range is limited to approximately 150 meters for effective use. He paused, looking at his notes. However, none of those limitations matter. What matters is that this weapon can be produced quickly, in vast quantities, with minimal specialized tooling. It can be operated by soldiers with minimal training. It can be carried by infantry without exhausting them, and it can destroy any armored vehicle currently fielded by any nation. He looked up from his notes, his expression grim. The Americans have democratized tank destruction. They have given every infantryman the power to kill armor. This changes everything. Major Wenzel added his perspective. From a tactical standpoint, this weapon eliminates many of our advantages. Our tanks can no longer operate with confidence near enemy infantry. Every American soldier with one of these tubes represents a threat that must be neutralized. Reconnaissance becomes exponentially more dangerous. Infantry support becomes mandatory. The entire doctrine of armored warfare must be reconsidered. Stein raised his hand tentatively. Herr Oberingenieur, could we not develop countermeasures? Additional armor, perhaps, or standoff screens to defeat the shaped charge? Kroger shook his head. Additional armor means additional weight. Our tanks are already pushing the limits of our engine technology and our logistics networks. Heavier tanks require stronger bridges, more fuel, more maintenance, and standoff screens add complexity and reduce mobility. The Americans have created a problem with no easy engineering solution. The room fell silent. These were men accustomed to solving problems, to finding technical answers to military challenges. But this problem had no comfortable solution. The Americans had not out-engineered them. They had out-thought them. They had recognized that effectiveness mattered more than elegance, that production numbers mattered more than individual perfection, that giving good enough weapons to many soldiers was better than giving perfect weapons to a few. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. That evening, Kroger stayed late in his office, writing the preliminary report that would go to Berlin. Outside, snow had begun to fall again, muffling the sounds of the proving ground. He wrote carefully, knowing that his words would be read by generals and perhaps by the Führer himself. But he also wrote honestly, because dishonesty in technical matters served no one. The American M1 rocket launcher represents a fundamental shift in infantry tank engagement doctrine, he wrote. Its effectiveness is not derived from technical superiority but from philosophical simplicity. Where German weapons emphasize precision and efficiency, the American weapon emphasizes accessibility and sufficiency. It is designed not for the perfect shot but for the adequate shot, delivered by adequately trained soldiers using adequately manufactured equipment. He paused, considering his next words carefully. The weapon system's greatest strength is its reproducibility. Every component can be manufactured without specialized tooling. Every operator can be trained without extensive instruction. Every tactical situation can be addressed without complex doctrine. The Americans have created a weapon system that scales infinitely with their industrial capacity. He sat back, reading what he had written. Then he added one more paragraph, knowing it might be censored but feeling compelled to include it anyway. It is the assessment of this office that the M1 rocket launcher cannot be effectively countered through technological means. Additional armor imposes unacceptable weight penalties. Standoff protection reduces mobility and complicates logistics. Tactical countermeasures require infantry support that is increasingly unavailable due to manpower constraints. The only effective counter to this weapon would be to prevent its deployment through strategic means beyond the scope of this report. He sealed the report and set it aside for morning dispatch. Then he opened a drawer and pulled out a bottle of schnapps that had been aging there since before the war. He poured himself a small glass and walked to the window, looking out over the darkened proving ground. Somewhere out there, in the bunker, sat the American weapon that would be copied, modified, and eventually deployed as the Panzerschreck. But Kroger understood what many would not. Copying the weapon was the easy part. Matching the industrial capacity to produce tens of thousands of them, training hundreds of thousands of soldiers to use them, supplying them with unlimited ammunition, that was impossible. Germany would build perhaps 40,000 Panzerschrecks before the war ended. America would build nearly 500,000 bazookas. The arithmetic was, as always, insurmountable. The wind rattled the window, and Kroger raised his glass in a silent toast. To the American engineer who had designed this crude but brilliant weapon, to the factory workers who would build it by the thousands, to the infantry who would carry it into battle. They had won this engagement before it even began. They just did not know it yet. And neither, Kroger thought sadly, did most of Germany. The work of replication began in January 1943. Teams of engineers and draftsmen worked in shifts, creating detailed blueprints of every component. The launcher itself was straightforward, but the rocket proved more challenging. The shaped charge liner required precise forming. The fuse mechanism needed to be reliable but simple. The rocket motor had to provide consistent thrust without sophisticated quality control. Stein led the rocket development team, working 16-hour days to solve problems the Americans had already answered. They experimented with different liner materials, different explosive compositions, different motor designs. Each iteration brought them closer to the American original, but always with the frustrating recognition that they were not innovating. They were copying. They were playing catch-up in a race they had not known they were running. By March, they had functioning prototypes. The launcher was nearly identical to the American original, though manufactured from German steel to slightly different tolerances. They called it the Panzerschreck, the tank's terror, and the name was apt. In tests, it matched the American weapon's performance almost exactly. It could penetrate any Allied tank at ranges up to 150 meters. It was simple to operate, relatively light to carry, and devastating in effect. Production began in April at multiple facilities, but immediately, reality imposed its constraints. The Americans manufactured their bazookas from readily available materials using simple processes. They had unlimited copper for electrical components, unlimited steel for tubes, unlimited explosives for warheads. Germany, in 1943, had limited everything. Every gram of copper was rationed. Every kilogram of steel was allocated. Every explosive charge competed with artillery shells and aerial bombs for resources. Preparing and narrating this type of story took us long efforts and hard work. So if you are enjoying the story, please consider subscribing to our channel. The production numbers told the story. In the first month, Germany produced 800 Panzerschrecks. The Americans, by then, were producing 7,000 bazookas monthly. The gap was not closing. It was widening. And every month, American production increased, while German capacity strained and cracked under Allied bombing and resource shortages. Major Wenzel, now promoted to Oberstleutnant and commanding a regiment, received his first Panzerschrecks in June 1943. He had requested enough to equip every platoon with at least one team. He received enough to equip one in 3 platoons. The weapons came with minimal ammunition, perhaps 3 rockets per launcher, because rocket production was even more constrained than launcher production. He distributed them to his most reliable NCOs and conducted brief training sessions. The weapon performed exactly as promised. His soldiers took to it quickly, understanding its tactical implications immediately. But Wenzel noticed something his men did not. They were excited to have a weapon that could kill tanks. They felt empowered. But Wenzel had read the intelligence reports. He knew the Americans were fielding these weapons not as precious resources carefully allocated, but as standard infantry equipment, issued as casually as rifles. Every American infantry company had multiple bazooka teams. Every American soldier had trained on the weapon. Every American supply truck carried rockets by the hundreds. His regiment had 9 launchers. 9. Against an enemy that would soon invade Europe with thousands. The arithmetic made him physically ill. In July, Wenzel's regiment was deployed to Sicily. Within 2 days of heavy fighting, he had lost 4 of his 9 Panzerschrecks, 1 to American artillery, 1 to a direct hit from a tank. 2 simply disappeared in the chaos of retreat, probably dropped by frightened soldiers or captured by advancing Americans. Replacements were promised but never arrived. Ammunition for the remaining 5 launchers dwindled to nothing within a week. Meanwhile, American infantry supported by armor pushed steadily inland. Intelligence reports mentioned bazooka teams constantly. They were everywhere, in every engagement, stopping counterattacks, destroying strongpoints, forcing German tanks to operate cautiously or not at all. The weapon Germany had copied was being used exactly as Kroger had predicted, not as a precision instrument carefully employed, but as a standard tool deployed with the casual confidence of unlimited availability. Wenzel survived Sicily but was badly wounded in the final days of the campaign. As he was evacuated to a hospital in Rome, he passed through a captured American supply depot. Stacks of wooden crates stretched as far as he could see. His escort, a young Luftwaffe lieutenant, noticed his interest. "American supplies, Herr Oberstleutnant. We captured this depot intact. You should see what they have." Wenzel insisted on stopping. He walked through the depot on crutches, his chest bandaged, and examined the crates with numb fascination. Bazooka rockets, thousands of them, stacked in organized rows, properly labeled, carefully packed. More rockets in this one captured depot than his entire regiment had fired during the entire Sicilian campaign. He opened one crate. The rockets inside were identical, perfectly manufactured, packed with maintenance manuals and instruction sheets in clear English. He sat down on a crate, exhausted and defeated. "They lose this much," he said quietly to the lieutenant, "and do not even care. This is what they abandon during a retreat." The lieutenant nodded. "We found American vehicles loaded with supplies. They burned them rather than let us capture them. Can you imagine? They have so much they destroy it rather than leave it behind." Wenzel closed his eyes. He could imagine it very well. He had been imagining little else for months. Back in Germany, Kroger continued overseeing Panzerschreck production. He attended monthly meetings where officials demanded increased output. He explained, patiently and repeatedly, that production was limited by resource availability, not by manufacturing capacity. They had the factories, they had the workers, they did not have the copper, the steel, the explosives, the time. By late 1943, German production had reached approximately 3,000 Panzerschrecks per month. Respectable, perhaps even impressive given the constraints. But Kroger had access to intelligence estimates of American production. The numbers haunted him. 8,000 bazookas per month, and increasing. By the end of 1943, the Americans would have manufactured perhaps 90,000 launchers. Germany would have produced perhaps 25,000 Panzerschrecks. And that assumed German production continued at current rates, which was increasingly unlikely as Allied bombing intensified and resources grew scarcer. In December, a year after examining the captured bazooka, Kroger wrote his annual assessment report. It was a technical document, carefully neutral in tone, focused on production statistics and performance data, but in the final paragraph, he allowed himself one observation. The Panzerschreck has proven to be an effective weapon system, performing at or above specifications in all combat trials. However, its strategic impact is limited by production constraints that cannot be overcome through engineering solutions. The enemy possesses equivalent weapons in quantities that render parity impossible. Tactical effectiveness is therefore diminished by strategic inadequacy. It was the most diplomatic way he could say what he truly believed. They had copied the weapon perfectly. It made no difference. The war would not be decided by which side had better anti-tank rockets, but by which side could build more of them, supply them consistently, and replace losses without pause. And that war had been decided long before the first Panzerschreck rolled off the production line. 1944 brought the inevitable. Allied forces landed in Normandy with the largest amphibious invasion in history. Among their supplies, packed carefully into landing craft and transported across the Atlantic with the same casual abundance that characterized everything American, were thousands of bazooka launchers and hundreds of thousands of rockets. German defenders, outnumbered and outgunned, fought desperately. They used their limited Panzerschrecks effectively, stopping American tanks, destroying vehicles, inflicting casualties. But for every German rocket fired, the Americans fired 10. For every Panzerschreck team, the Americans fielded 5 bazooka teams. For every German soldier trained on the weapon, 50 Americans had qualified. The arithmetic of attrition favored one side so completely that tactics became almost irrelevant. Stein, now promoted to a liaison position between the Ordnance Corps and combat units, spent much of 1944 visiting frontline units, assessing weapon performance, gathering feedback. He saw Panzerschrecks in action dozens of times. They performed well, soldiers loved them, they saved lives and destroyed enemy armor. But he also saw the other side. He saw supply trucks that never arrived. He saw ammunition shortages that left launchers useless. He saw replacements that took weeks instead of days. And he saw, in the tired eyes of soldiers who had been fighting since North Africa or Russia, the recognition that their best weapons were not enough. That effectiveness without availability was merely theoretical. that they were fighting a war they could not win because the enemy had answered every technical challenge with industrial capacity. In September 1944, Stein was at a forward command post when an American patrol was captured. Among the prisoners was a young private who had been carrying a bazooka. Stein, speaking reasonable English, asked the soldier about his training. The private, barely 19 years old, explained that he had received 8 hours of instruction on the bazooka during basic training. 8 hours. Stein's own soldiers received perhaps 2 hours if they were lucky, because instructors and ammunition for training were both impossibly scarce. "How many rockets do you carry?" Stein asked. The private shrugged. "Usually 4 or 5, but there's always more. Supply sergeant has crates of them. We can get more whenever we need." Stein thanked him and walked away. 4 or 5 rockets per man. Unlimited resupply. He thought of German soldiers rationing their precious 3 rockets, saving them for perfect shots, because there would be no replacements. The private probably had no idea how wealthy he was, how impossible his casual abundance seemed to an enemy who had learned to count every bullet. The war ground toward its conclusion. Panzerschreck production continued into 1945, though at declining rates as factories were bombed, workers conscripted, and resources exhausted. Total production reached approximately 350,000 units before the surrender. Not insignificant, perhaps even impressive, but the Americans produced 480,000 bazookas, and their production never faltered, never slowed, never faced the impossible choices between tank ammunition and infantry weapons, between copper for radio components or rocket motors, between steel for armor or launch tubes. Kroger survived the war. He was captured by American forces in April 1945 and interrogated briefly. The American intelligence officers were professional and courteous. They asked about various weapons systems, production methods, technical innovations. When they mentioned the Panzerschreck, one officer smiled slightly. "Based on our design, yes?" Kroger nodded. "Yes. Your M1 launcher. We examined a captured specimen in December 1942. Production began the following spring." The officer made notes. "We were flattered, actually. Imitation being the sincerest form of flattery and all that." He looked up from his notepad. "Did it help? I mean, did having your own version make much difference?" Kroger considered the question carefully. "It was an excellent weapon. Your design was brilliant in its simplicity. We manufactured it as well as we could given our constraints. But did it make a difference?" The officer persisted. Kroger smiled sadly. "No, it did not make a difference. You had too many. We had too few. That was always the problem, you understand. Not quality. Quantity." The officer nodded slowly, then closed his notepad. "For what it's worth, your version was well made. We captured quite a few. Good engineering." It was meant as a compliment, but to Kroger it sounded like condolence. Stein also survived, working briefly for the American occupation forces before emigrating to Canada. He wrote a memoir in the 1960s, published in limited edition by a small academic press. In it, he devoted an entire chapter to the Panzerschreck development. The final paragraph read, "We built a fine weapon. Our engineers solved every technical challenge. Our workers manufactured it as well as wartime conditions allowed. Our soldiers employed it bravely and effectively. But we were building with one hand what our enemy built with 10. We were conserving what they expended freely. We were rationing what they distributed, without thought. The weapon we created did not fail, but the nation that created it was already failing, and no weapon could change that mathematics. The Panzerschreck was our confession that the Americans were right. Simple weapons, produced abundantly, were better than sophisticated weapons produced sparingly. We learned the lesson. We applied it as best we could. It made no difference. The war was already lost." Major Wenzel, recovered from his wounds, commanded a battalion during the final months. He survived multiple engagements, surrendered to British forces in May 1945, and spent 2 years in a POW camp. He rarely spoke about the war afterward, but in a letter to a friend in the 1950s, he wrote about his experience in Sicily. "I remember passing through that American supply depot, seeing those crates of rockets stacked like firewood. That was when I truly understood. Not when Berlin fell, not when the Führer died, but when I saw how much they could afford to lose and not care. That was when I knew we had been fighting something we could not defeat. Not their soldiers, their factories." The Bazooka remained in American service for decades after the war. It served in Korea, in Vietnam, in dozens of smaller conflicts. Improved versions were developed, but the basic principle remained unchanged. A simple tube, a shaped charge rocket, a two-man crew. It democratized anti-tank warfare exactly as its designers intended. The Panzerschreck disappeared into history, a footnote in the story of World War II weapons. Museums display examples alongside their American counterparts. The similarity is obvious. So is the difference in production numbers. Today, military historians recognize the bazooka as a revolutionary weapon, not because it was technically sophisticated. It was not. But because it recognized that warfare had become industrial, that victory required not superior weapons, but sufficient weapons in overwhelming numbers. The Germans understood this, eventually. They copied the design. They manufactured their own version. They learned the lesson. But understanding came too late, and implementation came with limitations they could not overcome. Kröger lived until 1983. In his final years, he occasionally gave lectures at technical universities about weapons development. When asked about the Panzerschreck, he would describe the technical challenges, the production processes, the combat performance, and then, if he was feeling philosophical, he would add a coda. The Americans taught us something important with that weapon. They taught us that perfect engineering can be defeated by adequate engineering produced abundantly. They taught us that a soldier with a good enough weapon available immediately is better than a soldier waiting for a perfect weapon that never arrives. They taught us that war is not a test of ingenuity but a test of capacity. He would pause, looking at the young engineers in his audience. We learned the lesson. We applied it as best we could, but we learned it too late, and we applied it with resources we did not have. That is the tragedy of the Panzerschreck. Not that it was a copy, not that it was inferior, but that it was irrelevant. The war was decided by factories in Detroit and Pittsburgh and Cleveland. It was decided by workers who built weapons we could not match in numbers. It was decided by an industrial capacity we could not comprehend until we saw it with our own eyes. And by then, it was far too late. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.